Yes, welcome back guys on India's largest e-learning platform, that is BYJU'S Exam Prep. Yes, so guys, please tell me, am I properly audible and visible to all of you or not? Then we are starting the session. Yes guys, quickly. Yes, so here we are starting. Yes, Abhishek Gope, good afternoon dear. So as I already told you that today we are going to see the questions of previous year's GATE, which are from those GATE papers when IIT Kharagpur have conducted the exam. Yes, Manas, Krishan, yes. So let us move further guys without wasting the time. This is some detail about me, and today's subject is going to be production technology. Okay guys, so today's subject is production technology. This is the mechanical faculty at BYJU'S. So you can see every day we are taking the sessions on YouTube as well as on app. These are the 3 batches which are right now active. Vision GATE, this is for the student who are preparing for GATE. This is Rank Up GATE, this is for the student who want to just practice the questions, and this is the batch for the student who are preparing for 2023. Yes, Praveen, yes, Rama Teja, good evening dear. So let us start. So guys, first question is from material science. First question is from material science. Yes, the question is, the main purpose of spheroidizing treatment is to improve. Spheroidizing treatment is a kind of annealing process guys, and options are hardenability of low carbon steel, machinability of low carbon steel, hardenability of high carbon steel, machinability of high carbon steel. So my dear, what is going to be the right answer for this? And guys, as I said already that this series is going to be from IIT Kharagpur previous year's question. Okay, so it is going to be really very helpful. Yes guys, please tell me. Yes, Ankit Tripathi, good afternoon. What will be the right answer for this question? Spheroidizing annealing also it is said to be. Spheroidizing annealing. Yes. What will be the answer guys? Yes, Ernst Merchant is saying D. Hello dear. So guys, what about others? Answer kariye please. Okay, Kishan Ajudia is saying no idea. No issue dear, I am telling you. Very good, Kirti Verma. So dear, first point is the kind of heat treatment like annealing, normalizing, hardening, these kind of heat treatment processes whenever we are going to perform. So annealing, normalizing, they are always done with the medium or high carbon steel. They are not done with the low carbon steel. Why? Because low carbon steel is said to be mild because it does not respond to heat treatment. So first thing my dear, it will be high carbon steel. And my dear, yes, spheroidizing basically improves the machinability. So don't worry guys, if you are not knowing, you will be getting the answer. Okay, so spheroidizing is done to improve the machinability of the material. Good afternoon Devesh Singh Chandel. Yes, so dear, next question. And don't worry, for material science there are very less question. Then it will be from casting, welding and other topics. This is question number 2 guys. For this I will be giving you the hint. The ultimate tensile strength of a material is 400 MPa. So my dear, UTS is given as 400 MPa. Is it fine? And my dear, it is said that elongation up to maximum load, and the elongation up to maximum load is 35% if the material obeys power law of hardening. Power law of hardening says that sigma is K times of epsilon to the power n. This is said to be power law of strain hardening. And at ultimate tensile strength, n becomes equals to epsilon. And my dear, here the true stress strain relation is asked. So I would like to tell you that the true strain is given as, it is given as ln 1 plus engineering strain. And my dear, engineering strain is already mentioned as 35% elongation. So my dear, this is the true strain value. First of all, you will be very good Ernst Merchant, very good Ankit Tripathi, wonderful guys. So try to solve this. First of all, you will find out the true strain. You know that engineering strain is nothing but delta L upon L, and as you know it is 35%, so value will be 0.35. Put this value, got the value of true strain, it will give you the value of n as well. Okay, Yes, then my dear, you need to find out the value of K. It is already mentioned that ultimate tensile stress is 400 MPa. So you will be using this relation, okay, and you will be finding out the value. Yes, solve it guys. First of all, you will find out the true stress. True stress will be sigma naught 1 plus epsilon E. This is already given as 400 MPa. So my dear, with this you will be getting the value of true stress, okay, and getting this value you can find out the relation, you can find out the value of K. Kirti Verma is saying D, Madhu Verma is saying B, Ernst Merchant is saying B. Wonderful guys. So when you will be putting this value, what you will get as a true stress? True stress will be coming out to be 540. It will be coming out to be 540, and my dear, true strain will be coming out to be equals to, the answer for this is, it is going to be 0.3. Yes. So my dear, now you will be writing true stress is 540 is equals to K times 0.3 to the power 0.3. From here you will get the value of K to be 775. Okay, and once you get this value, the equation will be sigma is equals to 775 epsilon to the power 0.3. So guys, answer for this is going to be B. Is it fine? Wonderful. Parvinder Singh, wonderful guys. So let us move to the question number 2 guys. Quickly like and share the session and share it in all the Telegram channels and WhatsApp groups. This is related to, my dear, the testing. Sharpie test, noob test, spiral test and cupping test. Okay, and these are the properties: fluidity, micro hardness, formability, toughness and permeability. Yes. So which is going to be the right answer guys? Which is going to be the right answer? So my dear, actually whenever this type of question comes, Madhu Vamshi, that I am going to take in November. In November, Tom will be there in your vision batch. Okay, so don't worry about that. My dear, when you get this type of question, you would not be knowing about all the 4 options. You will be knowing about 2 to 3 options, and 4th option you can identify just by going through the options. So when you will be going through the options, you will be able to get the right answer. Yes, Ernst Merchant is saying the answer to be D. Very good. Very good, Ernst Merchant. Parvinder, what do you say? Kirti Verma, yes, Parvinder is saying D as well. Yes, Ram Ganesh Gupta, good afternoon dear. Yes guys, so today it is going for production. Every day at 3 PM we are going to meet for different subject. Surya Singh is also saying D. Okay, as production is a big subject, for production we will be having 2 sessions. For SOM and MD we will be having 1 session, because MD and SOM questions are not much. Production questions are more than 60, so we cannot have in 1 session, we will be having in 2 sessions. Madhu Verma D. Guys, one more thing I would like to ask, do you like me to add PI questions as well? If you will say I can add PI question, production industrial gate paper question also in that, then the number of questions will increase and we have to go for 3 sessions of that. So guys, when you are going for this, you already know Charpy and IJO test are done for the toughness. So my dear, first of all, P is going to join with 4. So either A or D will be the answer for sure. Noob test is a test done for hardness basically. Okay, so obviously for hardness there is only this micro hardness is written. So Q is with 2. So just by these 2 you can answer that the right answer is going to be D. Okay, so R, spiral test is done. Spiral test is done for fluidity and cupping test is done for the formability. So in that way the answer is going to be D. Yes, Manas, very good. Fine guys, fine. So we will definitely add them. So today we are having mechanical questions only. The process of reheating the martensitic steel reduce its brittleness without any significant loss in hardness. So my dear, what is going to be this process? This is once again from heat treatment. Yes, once again from heat treatment. Very good guys, very good. You guys are doing wonderful. And guys, as you already know, one new type of question have been there from last year, that is MSQ, multiple select questions. And guys, at 5 PM on app, on BYJU'S Exam Prep app, we are preparing, we are going for MSQ series at 5 PM. 2 sessions are already been over. Those students who want to get the feel of MSQ can go through that series that is taken by me. Okay, and today there also the subject is production. Very good, Manas, Kirti Verma, Ernst, Kishan. So answer is going to be D for this, because tempering is done after hardening. So when we get the martensite structure, after that, my dear, we are going for the tempering process. Yes, guys. Match the heat treatment process, Group A, and their associated effects and properties, Group B, of medium carbon steel. Tempering, quenching, annealing and normalizing. Yes, guys, what will be the answer? Tempering, quenching, annealing and normalizing. You can see right hand side, it is hardening, it is softening, it is inducing toughness, it is strengthening and grain refinement. Yes, guys, what would be the right answer? What would be the right answer? We have just seen tempering. Yes, very good, guys, very good. We have just seen tempering was inducing the toughness when already material is having hardness. So my dear, there shall be no doubt about that, that tempering is going to induce toughness. So answer would be either D or B. Yes, one more chance. Loga Vignesh is saying B, Surya Singh is saying B, Ernst Merchant is saying B. Okay, what about others? Yes, Kirti Verma, very good. So guys, then you can see quenching is done with the hardening. So my dear, still we can say answer is either B or D. Then my dear, annealing is going to soften the material. So the answer will be B for this. Wonderful, guys, wonderful, बहुत ही बढ़िया. Yes. So guys, now we are entering into the casting questions. Kishan, very good. Parvinder, very good. This is the casting question. Disposable patterns are made up of. Disposable patterns are made up of wood, rubber, metal or polystyrene. What will be your answer? Disposable pattern. Disposable pattern are made up of wood, rubber, metal and polystyrene. Sanin Sheikh is saying D. Ernst Merchant is saying A. Chandrasekhar saying D. Kirti Verma D. Loga Vignesh D. Manas, yes, D. Ernst Merchant D. Okay, fine, guys, fine. So guys, the answer is D for this. Polystyrene. This is said to be disposable pattern. Next, my dear, expandable pattern is used in flush casting, squeeze casting, centrifugal casting, investment casting. This can tell you that majority theory questions are coming from the applications only. Okay, major theory questions are coming from the applications only. What would be the answer for this question, guys? What would be the answer for this question? An expandable pattern. Next question is going to be numerical. Yes, now numericals are coming soon. Devesh is saying D. Chandrasekhar is saying D. Kishan is saying D. Sanin is saying D. Manas D. Ankit D. Ernst D. Parvinder D. Wonderful, guys. Wonderful. The answer is D. It is true. Investment casting uses wax patterns which are made up by centrifuging. Which are made up by centrifuging. Centrifuging. This is the 8th question, my dear, from casting once again. And my dear, this is asking the relation between TA and TB, which are the time taken to fill the cavity by top and bottom gating system. So guys, now you need to answer it. Yes, guys. In a sand casting operation, the total liquid head is maintained constant such that it is equal to the mold height. The time taken to fill the mold with the top gate is TA and with the bottom gate is TB. Ignore time required to fill the runner and frictional effect. Assume atmospheric pressure at the top molten metal surface. The relation between TA and TB is, what is the relation between TA, which is time for top, for bottom? What will be the answer, guys? Yes, Kishan, this is for mechanical. Devesh Singh, this is for mechanical going on. Okay. Yes. Then how you are answering for mechanical? Surya Singh, Sanin Sheikh, Manas, Ans Merchant, Parvinder, Ankit. Wonderful, guys. The answer for this is going to be B. The time required to fill the cavity by bottom gating system will be 2 times than that of the top gating system. And my dear, always bottom gate system takes more time than that of top gating system, and that is the reason we prefer top gating system. And there are some advantage with bottom gating system as well. Dross formation is more with the top gating system. Okay, so let us move to the next question, guys. I would like to tell you we are soon coming with the wonderful series, qualified series, which was a blockbuster last year. And there we are going to discuss the important topics of complete subjects of mechanical engineering. You guys are going to love that series. Match the casting defects with the probable causes. My dear, hot tears, shrinkage cavity, blowholes and cold shut. So they are the defects, and this is the reason for the defect. So my dear, you need to tick the right answer for this question. Yes. And after that we are having 3 to 4 continuously numerical. Yes, Kishan, you are correct. Wonderful, wonderful, dear. Swans Merchant, what is the answer for this? Kishan, what is the answer for this? Chandrasekhar is saying the answer to be B. Bahut badhiya. What about you, Kishan, Baldev, Sanin, Surya, Manas, Parvinder, Ankit? What will be the answer, guys? Ans Merchant is saying the answer to be B. बाकी लोग भी बताइए भाई, सभी लोग बताइए भाई. So my dear, daily we are covering one subject. Production will be covered in two times because it is a bigger subject. So every day we are having at 3 PM this session of previous years GATE of IIT Kharagpur years. Sanin Sheikh is saying B. Parvinder Singh is saying B. Manas Jyoti Das is saying B. So guys, answer is B only. So my dear, when we are saying hot tears are coming due to the differential cooling rates. Then my dear, shrinkage cavities are always there due to the shrinkage. So there the reason will be going to be volumetric contraction both in liquid and solid state. This happens when we are going to have the solidification. There are of two types solidification. One is skin forming, other is dendritic growth. So this happen at the time of dendritic growth. Then my dear, blowholes are going to be there due to low permeability, and cold shut is due to improper fusion. So my dear, that is fluidity is the reason. Question number 10, guys. This is a numerical. This is a kind of top riser. First of all, you can see the riser is a top riser. So this is a top riser. A cylindrical blind riser with diameter D and height H is placed on the top of the mould cavity of the closed type sand mould as shown in the figure. If the riser is of constant volume, then the rate of solidification in the riser is the least when the ratio of height to the diameter is. Sir, is this session will be uploaded for offline? Dear, yes, these sessions will be available on YouTube, but I will suggest you to join live only, because in live you will get more clarity, because on the same time you can ask doubts as well. Okay, and as I said, if you are interested in MSQ, join me on app at 5 PM. Manas is saying A to be the answer for this question. Okay, what about others? What about others? For this we have derived in the classes many times. Baldev is saying A. Very good, Baldev. What would be the answer, Kishan, Surya, Sanin, Parvinder? Surya is saying A. Bahut badhiya. बहुत बढ़िया सूर्या. Ernst Merchant, very good. So you are doing really well, Ernst Merchant. What is your real name, Ernst Merchant? Parvinder Singh, very good. Very good, Parvinder. Yes. Definitely, Baldev. That's why live session have their own importance. So guys, I will suggest you must come to MSQ series at 5 p.m. You will learn a lot from that as well. 2 sessions are been over of design. Today will be for production. It is hardly half an hour session where you will get the feel of MSQ. So guys, a cylindrical blind riser with diameter D and height h. You can see this is the diameter and this is the height h. And you know that this surface is going to be with the contact of the cavity. So to the atmosphere only 2 surfaces are going to be there. One is this, other is this. So if I write the volume of riser, it is pi by 4 d square h. If I ask you the surface area of the casting, of the riser, it is going to be pi by 4 d square plus pi dh. Now my dear, there are 2 variables d and h. If I want to write it in one variable, you can write h is equals to 4v by pi d square. So pi by 4 d square plus pi d, h will be 4v by pi d square. So my dear, this is the surface area. And if you want to minimize the time, because we want riser to maximize, riser to solidify in the last, we want riser to solidify in the last. So my dear, obviously the time required for solidification should be more, and for that surface area should be less. So we will be minimizing the surface area, because less surface area means slow cooling, means more time for solidification. So when you will be going for the d of surface area with respect to d differentiation, you will get pi by 4 into 2 times of d plus d se d have already been cancelled out. It is coming out to be minus 4v by d square. Okay, it is going to be the case. And when you will be doing it equals to 0, then my dear you will be getting diameter to be equals to height. So it is going to be 2r. It has been asked the ratio of h versus d. So you will be getting diameter is equals to r basically. Sorry, I have written it wrongly. You will be getting r is equals to height for top riser. R is equals to h. So my dear, r is d by 2 is equals to h. So h by d will be 1 by 2 or d by h will be 2. This is how you can solve it. Now the question is, guys, from the metal forming. Definitely Manas, it will be available. This is going to be the question for the metal forming. A 4 mm thick sheet. So initial thickness is 4 mm. Initial thickness is 4 mm. Is rolled with a 300 mm diameter. So my dear, the diameter of roller is 400 mm. To reduce the thickness without any change in its width, width is going to be constant. Friction coefficient at the work roll interface is 0.1. The minimum possible thickness of the sheet that can be produced in a single pass. You need to find out H minimum, H final minimum. What will be the answer? So you know that delta H is H naught minus H final. My dear, this H final will be minimum when delta H will be maximum. Solve it, guys. Chandrasekhar is saying C. Ankit Tripathi is saying C. Parvinder Singh is saying C. So my dear, delta H maximum, if you do not remember the formula, I am giving you, it is given as mu square R, where R is the radius of roller. Here diameter is given, be careful. It is not 400, it is 300. you will be putting the diameter in place of radius, you will be getting wrong answer. Yes, it is 300 only. So my dear, delta H maximum is going to be 0.1 ka square. Radius will be 150. So it is going to be 1.5 mm. So my dear, delta H maximum is 1.5 mm. 4 mm minus HF minimum. So you will be getting 2.5 mm as the answer. बहुत बढ़िया guys. Kumari Mahesh, Sanin, wonderful guys. Let us move to question number 13. In a wire drawing operation, diameter of a steel wire is reduced from 10 mm to 8 mm. So my dear, initial diameter was 10 mm. Final diameter is 8 mm. The mean flow stress is 400 MPa. 400 MPa. The ideal force requirement for drawing. Ideal means you need to ignore the friction and redundant work. So my dear, you need to find out the drawing force requirement. Very good question. So guys, solve this and get the answer. Wonderful guys. You guys are doing great. Kishan, Baldev, Kumari Mahesh, Sanin, Chandrasekhar, Ernst Merchant, Parvinder, Ankit. Sanin, what is going to be the answer for this? क्या होगा इसका आंसर? हिंट दे देता हूं. ड्रॉइंग स्ट्रेस इज, ड्रॉइंग फोर्स इज mean flow stress ln r into a final. Here r is initial area to the final area. R is also said to be extrusion ratio. This is said to be the drawing stress. This is said to be the drawing stress. Yes, guys. वंडरफुल अंकित, सूर्या, अंश मर्चेंट, बहुत ही बढ़िया, शानदार. So drawing force will be mean flow stress is 400 ln, it is going to be d initial square by d final square, 10 का square by 8 का square into final area pi by 4 8 का square. Surya B, Ankit Tripathi B, Midun, welcome to this session dear. Answer will be coming out to be B, 8.97 kilonewton. Wonderful guys. This is a very easy question. The relation between true strain and engineering strain is given by. Very easy question. Yes, this relation we have written 2 to 3 times in the previous questions. Kishan is saying B. सोच समझकर लिखिए. Chandrasekhar is saying C. Ankit Tripathi C. Manas C. Amit C. बलदेव सी, परविंदर सी, बहुत बढ़िया. गाइस द आंसर इज सी. ट्रू स्ट्रेन इज ln 1 plus engineering strain and true stress is engineering stress into 1 plus engineering strain. These are the relation under tension. For compression minus sign will come in between. Yes, once again from metal forming. This is 1 plus t square, not t2 square. You need to find out the true strain rate. You need to find out epsilon t by dt because its unit will be minute inverse. Length is given to you guys. Solve it and get the answer. Solve it and get the answer. Solve it and get the answer. Very good guys, very good. Solve this question. Wonderful. Okay, Parvinder have answered as 1 minute inverse. 1 minute inverse. बहुत बढ़िया. Baldev is saying 2 minute inverse. This is a numerical answer type. No negative marking. Either +2 or 0. कुमारी महेश, वंडरफुल डियर. 2 आंसर आ रहा है आपका. चलिए. What about others? So L as a function of time is L naught 1 plus t square. We will differentiate dl. We will get as L naught 1 का 0 t square का 2t dt. So this is the dl. My dear, you know that strain is defined as dl upon L as a function of t. So when you will be putting this value, you will be getting d of epsilon t as dl is L naught into 2t dt divided by L naught into 1 plus t square, and dt will go down, d epsilon t by dt, which you need to find out. This is L naught will get cancel out. 2t by 1 plus t square. Put t to be equals to 1. You will be getting 2 into 1, 1 plus 1. Very good answer, merchant. Kishan, बहुत बढ़िया. 4 students have given the right answer for this. Question number 18, guys. What would be the answer for this time? This time they are asking, in a rolling process, the maximum possible draft defined as difference between initial and the final thickness of the sheet metal mainly depends on which pair of the following parameters: strain, strength, diameter, velocity, coefficient of friction. What will be the answer? This type of question have also been asked already in GATE 2011. तो ये पहले भी पूछा गया था, उसके बाद ये रिपीटेड क्वेश्चन है. ठीक है, कभी कभी क्वेश्चन रिपीट होते हैं गेट में, रेयर होते हैं. कॉन्सेप्ट वही रहता है, बस डेटा चेंज होता रहता है. परविंदर इज सेइंग बी, अंकित इज सेइंग आर टी, सनीन बी, कुमारी महेश बी, राहुल बी, अंश मर्चेंट बी, राहुल बी. ओके, so dear, you know delta H maximum formula already. So delta H maximum is mu square R. So my dear, obviously mu and R. So diameter and T, R and T will be the answer. Next question is 19. A mild steel plate has to be rolled in one pass such that the final plate thickness HF is 2 by 3 H naught. With the entrance speed V naught is 10 meter per minute and roll dia is 500 mm. If the plate widens by 2%, means width is also changing. B final by B initial is 1.02. during rolling, the exit velocity, V final, you need to find out. So guys, in such case, you can do one thing. You can assume initial volume to the final volume. It is B naught, H naught, V naught. B final, H final, V final. You need to find out the V final. Okay. For H and B, it is mentioned, and initial velocity is also mentioned. Solve this. Very good question. Chandrasekhar 14.7, अंकित त्रिपाठी 14.28. ओके, बाकी लोग भी बताइए. What about others? What about others? Yes, guys. बहुत ही बढ़िया. मानस 14.7, कुमारी महेश 14.7, कीर्ति वर्मा 14.7, सूर्या सिंह 14.7. Yes, in bar question repeat from GATE. Kishan 14.7. Yes guys, the answer will be 14.7. You just need to put the all values, you will get 14.7. This is correct. A rectangular hole of size 100 mm cross 50 mm is to be made on a 5 mm thick sheet of steel having ultimate tensile strength and shear strength as 500 and 300 ampere. The hole is made by punching process. Neglect the effect of clearance. The punching force in kilonewton is. Guys, you know that the formula for punching force requirement is going to be shear area into tau ultimate. So shear area, this time the hole is going to be rectangular. Hole is going to be rectangular, this type of hole, whose 150 are the width and length, 5 mm is the thickness. So my dear, shear area for this case is going to be perimeter into thickness. Perimeter is nothing but 2 into 100 plus 50 into thickness is 5. Now I feel you can answer it, because circular hole you have seen many number of times. Very good, Ankit Tripathi, Sanin Sheikh, Ernst Merchant, Parvinder Singh. Please answer it. I feel only 2 students have answered yet. Sanin and Ankit. Parvinder, very good. What about others? What about others? What about others? कुमारी महेश बी, कीर्ति वर्मा बी, बहुत बढ़िया, वंडरफुल गाइस. Baldev is saying D, Kirti Verma is saying 450. Yes, answer is 450 guys. So you will find out the punching force. Shear area is 300 into 5, it is in mm square, into 300, 450 Newton. Dear, 500 is the tensile strength, you need to use the shear strength. So that's why you are getting wrong answer, Baldev. So answer will be B but not D. B will be the answer. We need to use the shear strength, na? Operation is shear. 21 is from welding. In an arc welding process, the voltage and current. Voltage is 25 volt. Current is 300 ampere. Heat transfer efficiency is 0.85. Welding speed is 8 mm per second. Heat input in joule per mm. Yes, guys. Ankit Tripathi, very good. So when you want to find out heat input, first of all, efficiency times V into I divided by welding speed, because they have asked answer in joule per mm. Efficiency is 0.85. divided by welding speed. Answer will be 797. Very good, guys. Solve this question. The major difficulty during welding of aluminium is due to its. aluminium को welding करने में कहाँ दिक्कत आती है? High tendency of oxidation, high thermal conductivity, low melting point या low density. What will be the answer for this? Very good. Ernst Merchant, Chandrasekhar, Manas, Baldev. Wonderful, guys. Ankit Tripathi. बहुत बढ़िया, guys. मिथुन, बहुत बढ़िया. Parvinder, very good. Kirti Verma, very good. Answer will be A. Guys, actually all the metals have a bad habit. Then whenever any metal is in heated state and it see oxygen, it immediately reacts with oxygen and make the metal oxides. That is the habit with all the metals, first thing. So my dear, aluminium is highly reactive out of them. Other metals do this at higher temperature, but aluminium can do this even at room temperature. So even at room temperature it makes the oxide layers. So my dear, these oxide layers, when it becomes Al2O3, which is a ceramic ionic solid, and that is that much hard material that we are even using it as an abrasive material for cutting. So my dear, this is hard and brittle. So my dear, that is why it is difficult to weld upon. So always at room temperature aluminium will be found with a layer of Al2O3. So it is very difficult to weld. So we are welding it by cathodic cleaning process of TIG. Okay, yes. Next question. Question number 24. Within the heat affected zone, in a fusion welding process, the work material undergoes microstructural changes but does not melt. Neither melting nor microstructural changes. Both melting and microstructural changes after solidification. Melting and retains the original microstructure after solidification. Very good, Surya Singh. बहुत बढ़िया. Ernst Merchant is saying A. What about others? Baldev is saying A. Parvinder Singh is saying A. बहुत बढ़िया. Wonderful, guys. Midun is saying A. Wonderful. So guys, the answer for this is A. Because whenever we are going for heat affected zone, this is the zone where uncontrolled heat treatment takes place. So because of that, the crystal structure changes there. But my dear, it does not melt. Only microstructural changes happen. So answer will be A for this. My dear, next is a numerical. For spot welding of two steel sheet, Base metal each of 3 mm thickness. Welding current is 10,000 amperes. Welding current is 10,000 amperes. And time for which it is applied is 0.2 second. The heat dissipated to the base material, heat loss is 1000 joules. Assuming that the heat required for melting 1 mm cube, volume of steel is 20 joules. So heat requirement is 20 joule per mm cube. And interfacial contact resistance between the sheet is 0.0002 ohms. The volume in mm cube of weld nugget is. The volume in mm cube of weld nugget is. So my dear, you already know, first of all, heat generated can be calculated as I square RT. This is heat generated. Heat required is heat generated minus heat loss. And it can also be written as joule per mm cube into volume of weld nugget. So from here you can find out the volume of weld nugget. This is very easy question, guys. I want the answer from all of you. Chandrasekhar, Ankit Tripathi, Sanin, Kirti Verma, Kumari Mahesh, Ans Merchant, Midhun, Parvinder Singh, Baldev and Surya Singh. Ankit Tripathi saying 200 mm cube. Okay. What about others? What about others? Parvinder Singh is saying 150 mm cube. Okay. Sanin is saying 150. बहुत बढ़िया. Chandrasekhar is saying 150. Yans Merchant is saying 150. Kirti Verma is saying 150. Ankit Tripathi is saying 150. Kumari Mahesh is saying 150. And the answer is 150. Okay. First of all, I square RT you will go for. Then heat loss you will be subtracting, and then you will be just finding out it. Okay. So it is going to be 150. When you will be going for this, it will be coming out to be 4000. You will get heat required to be 3000, and then you will get volume to be 150. Now metal cutting, guys. हाँ, यही गलती कर दी अंकित. चलिए, what is now? This is from metal cutting. So guys, soon I will be coming with metal cutting sessions on YouTube. So be ready for that. Okay. As it is a very, very important topic. So a built-up edge is formed while machining ductile material at high speed, ductile material at low speed, brittle material at high speed, brittle material at low speed. Baldev is saying answer to be B. Parvinder Singh is saying B. Ankit Tripathi is saying B. बहुत बढ़िया. Sanin Sheikh is saying B. Ernst Merchant is saying B. Kumari Mahesh A. Manas B. Chandrasekhar B. So my dear, I would like to say that whenever we want the continuous chips and discontinuous chips, the criteria is like that. Continuous chip you will get when the material is ductile. You will get this when the material is brittle. Continuous when the speed is high. Discontinuous when the speed is low. Continuous when the feed is low. Depth of cut is low. Discontinuous when the feed is more, depth of cut is more. So my dear, if you consider first factor of continuous and other factor of discontinuous, you will get the build-up edge. So ductile material at low speed will be the answer. So ductile material with less speed, less feed and less depth of cut. Okay, sorry, more feed and more depth of cut, you will get build-up edge. Question number 27. बहुत ही बढ़िया guys. Kirti Verma, did you get it? So 27th, abrasive material used in grinding. Abrasive materials used in grinding will selected for grinding ferrous alloys. Options are silicon carbide, diamond, Al2O3 and boron carbide. What will be the right answer for this? Yes, what will be the right answer for this? We will do 30 questions today. So 3 questions left. Rest 30 question in the next session. Total there are 60. They are the questions from 3 years only. Parvinder Singh, very good. What about others? Kirti Verma is saying A. So guys, I would like to tell you that we use Al2O3, okay, for grinding the ferrous alloys. Al2O3 is used for that. Okay. Next, uncut chip thickness, cutting speed, rake angle, width of cut, chip thickness, thrust force, cutting force. Assume Merchant's theory, the value of shear angle and shear strain are. So my dear, solve this question. You know chip thickness ratio is T1 by T2. This is T1, this is T2. Once you will get the value of R, you can find out tangent phi. What is tangent phi? It is R cos alpha by 1 plus R sin alpha. Alpha is the rake angle. You will get the phi. Okay. After getting the phi, shear strain rate is cot phi plus tangent phi minus alpha. Solve this question, guys. Hint is there for you. Is it fine? Yes. Ramanna is saying C. Kumari Mahesh is saying C. Wonderful, guys. क्या आएगा आंसर? सोचकर आंसर करें. Kirti Verma is saying D. Parvinder Singh is saying D. Yes. Ansh Merchant D. Chandrasekhar D. And guys, yes, the answer is D. 40.28 you will get here. Some students just by finding out this have ticked C. This also you need to calculate. It will be coming out to be 1.652. सूर्या सिंह डी. बहुत बढ़िया, शानदार गाइस, बहुत ही बढ़िया. क्वेश्चन नंबर 29. The same data, this time they are asking you the coefficient of friction. The same data, this time they are asking you the coefficient of friction. Okay. And coefficient of friction is coefficient of friction is friction force but a normal force. And you very well knows friction force is Fc sin alpha plus Ft cos alpha. And normal force is Fc cos alpha minus Ft sin alpha. Put the values, get the answer. Yes. What will be the answer, guys? Kumari Mahesh is saying B. Chandrasekhar is saying B. Baldev is saying D. Yes. Ankit Tripathi is also saying B. Parvinder Singh is saying B. Ramanna is saying C. Guys, the answer is B. Coefficient of friction you will get as 0.46. Okay, by putting all these values. B would be the right answer. So guys, now for the same data, the third question is percentage of total energy dissipated due to the friction at the tool chip interface will be. Okay, so my dear, first of all you will find out the friction force. We have seen the formula in the previous question. Fc sin alpha plus Ft cos alpha. Find out the friction force. Okay, and after getting friction force, yes, solve it guys, solve it. After getting the friction force, you will find out the chip flow velocity. After getting chip flow velocity, you know that power is cutting force into cutting velocity. Then you need to see that F into Vf divided by FCVC into 100, how much percentage it is. Okay, yes, cutting speed is already mentioned, so you need to find out Vf. Can you find out V sin phi divided by cos phi minus alpha? Solve it. V is Vc, cutting speed. All the formulas are in front of you. Ramanna is saying A, Ankit Tripathi is saying A, Kirti Verma A. Very good, Ramanna. This is the last question for this session. Actually, there are 60 questions. So rest 30 we will do in the next session because they are 1 hour session. So guys, production is a big subject. So we are doing it in second 2 sessions. As many students requested for P and I will add good questions of P and I. Okay, so ME plus PI. So next session will be of more than 1 hour. It would be for 1.5 hours. Okay, and production next session will be at the end. Now be ready for tomorrow, the next subject session. Thermal part will be coming. Manas is saying A, Parvinder is saying A. So answer here is coming out to be A only. My dear, when you will be finding out the friction force, it will be coming out to be 503.8. When you will be finding out the flow velocity, it will be 0.713 times of cutting velocity. When you will be putting this value, it will be coming out to be 30%. Yes. So guys, please tell me, did you like this session or not? In the next session, actually in this series, I will be taking SOM MD as well as TOM vibration. So I am taking SOM, MD, TOM, vibration and production. So one session will be for SOM and MD, one session will be for TOM and vibration, and one more session will be there for production. Thanks Parvinder, thanks to all of you. And once again I am announcing at 5 PM you can join me on app for MSQ session. Today MSQs are also related to the production only. So take the benefit of MSQ. Thanks guys for your wonderful words. And goodbye for this session.